Welcome back, Math 9. Today we are going to go through Statistics and Probability Unit, lesson number 4 or chapter 4, which is about selecting a sample. So it is part of a sampling process, which, if you guys recall, sample is a small portion out of a population of your interest. Before we get things started, let me ask you a question. Why can't we do an entire population survey all the time? So you may wonder if we can get the most accurate result from any of a survey if we target an entire population. Where's my highlighter? But what stops us from doing that? I want you to write down about 2 reasons if you can think of. You can pause this video. Now I assume that you guys create some possible answers, so I'm gonna go through some example of why it is tricky to do an entire population survey all the time. So one situation is this. If you try to target the entire population, there is a time that plays a huge factor. So if you think about the entire population generally, collecting the answer, I don't want to say answer, sorry. It's like collecting samples from the population take a longer time, and analyzing time definitely become more than double. The second situation that you can think of is cost. Imagine if you're doing any type of paper survey and mail, those kind of situation. The one that has the questions. There will be some that goes to waste because you over produce most of the time. And mail cost can be another one. Now let's think about any limitation. Limitation of using sampling. So what I mean by that is why people are not doing it. Well, if you think about limitation, there are a few things that you can think of. In order to generalize the pattern, we have to undergo presumption. The fancy way of saying we have to assume something. And when I say assume, that can be, for instance, whatever this is the entire population, let's say. And imagine you took some of those survey from this area. So some kind of local situation. One of the assumptions that you have is whatever the pattern that you find must apply other places that you can think of within that population. So that itself is a big of an assumption. And here's another thing. We also assume when we do the sampling that whatever the random sampling that we did, so we're going to look at a lot of sampling technique today, but most of the time when you do the sampling, it is out of the hat. Let's put it that way. Whatever the random, sometimes we overemphasize about this random, because the thing is, yes, it is true that probability itself talk about random event. However, does it always apply for the whole population? Sometimes we have something called trend and pattern. Unfortunately, if you think about the random sampling that represent the whole population, and if, let's say, the sample has a trend or pattern, then it can be a problem. It may not be applied for entire population. Or if the random sampling doesn't have a trend or pattern, but if you look at holistically, population may have a trend or pattern, then that may not apply the whole thing. So those are the possible limitations. So today we are going to go through 6 different types of sampling methods. And this is quite significant because when you try to do your group project, which is a main project for this unit, you need to decide what kind of sampling method that you guys will do. And you will choose few different types and then you are gonna compare. So it can be 2 different situations, if you will. Now, one is known as simple random sampling. Simple random sampling. Simple random sampling represent each member of the population has an equal chance of being selected. So like the word suggests, and like I mentioned, this is one of those good old random pattern where randomly picked out of the hat. That is a situation. Each member of the population have an equal chance. If I pick, let's say, 3 people out of 30 people, that means everybody have a 1 out of 30 chance. So this is an example. Let's say 3 students are randomly selected from a hat for helping Miss Cote's HSTV production. So imagine 3 students, let's say entire population of HSCS. If we have, for instance, 300 people, let's say the total, I don't think we have 300 students, but in any case, then the probability of having this event is 1 out of 300 every time that Miss Cote is taken out of the hat, and that probability is initially apply for every single student in that random hat. Think about that way. I believe if you go through a movie, or what was it, the one that Jennifer Lawrence is in, Hunger Game, there you go, Hunger Game, it's kind of like that boat. Unless I didn't fully watch the movie, unless there's a little twist, then sorry. The second type of sampling method is known as systematic sampling or interval sampling. I want you to look at this picture first before you go through the description. There is a person number 1 all the way to 12. You may notice that 1 is not there. Second one's chosen. 3, 4, they skip. 5th one chosen. 6, 7, they skip. 8th one chosen. 9, 10, and it goes to 11. Those kind of things. So if you notice in here, you may find the fact that there is a pattern. For instance, 2 skipping happen between 2nd and 5th, 6 and 7 skipping, then 8, 9 and 10 skipping, and 11. And if I continue, you may understand that 12 will be skipped, and then 13 will skip, then 14 will be chosen. Similarly, 15, 16 skip, 17 chosen. So at this point, you may find that systematic or interval sampling have to have some kind of pattern. This is a sampling method that uses a pattern. So here's a definition. Every nth member of the population is selected. So what I mean by that is, if that can be every 3rd member, every 5th member, something like that. And in order to do that, maybe the system have random amount of population, or it can be smallest to largest or shortest to tallest. You guys may remember taking a group picture. Sometime it goes tallest to shortest or other way around. Then there can be some pattern that happen. Let's say every 5th people from shortest to tallest will be the one that moved to the next row, something like that. Example, every 50th Pepsi Cola, you know, the aluminum can, 500 ml can is tested for endurance test, something like that. So maybe every, let's say there is a 200 Pepsi Cola, then there will be 4 random sample because 50, 100, 150, and 200, something like that. And every 50th one will be tested for endurance test. And that's what manufacturers do randomly. And if, in this case, an item is destroyed or unusable, we call that sample a destructive sample. So that's the one that people check for quality assurance, if you will. Let's keep going. Cluster sample. As you may notice, we're picking certain group. Like randomized group, we have second and fourth, something like that. So cluster sample is we're picking a group. Every member of each randomly chosen group of the population is selected. So there are a lot of groups exist. If you think about, let's say, Edmonton, imagine randomly people choose a district. What about Millwoods? What about Rosenthal? What about even when you think about reserve situation, what about River Cree? Those kind of area. So it is cluster. It can be very localized too. So this is a school type example. One random grade in HSCS, which is K-9 school, is chosen randomly for a survey. All members from the chosen group must do a survey, something like that. So we are doing some kind of survey, but we're choosing a cluster. So in this situation, let's say we're having some kind of survey that evaluate teachers' instruction style or how good they're teaching, something like that. Random sample can be chosen, so something like it can be grade 6. There is some realistic problem though. Do I teach grade 6? Not really. The other type is known as self-selected sample. And quite a lot of scientific experiment does it. And you will see a quick example that I put some working out example. Both, if you are into workout, both of them are vertical type of back muscle workout, except the first one use machine and second one is free weight situation, which is your body pull-up situation. So how can self-selected work? First of all, think about it as volunteer situation. Only members who are interested, and only members that wanna volunteer will participate for this entire survey. You can think it in that way. So what I mean by that is this. Quick example, like I suggested in this workout situation, participant of the science experiment about muscle mass gain versus different weightlifting routine can be this situation. Imagine I conduct a survey and I'm the one who studies muscle mass, your back muscle mass, and how much gain using 2 different methods, in this case machine assisted versus freestyle pull-up. I have participant that is interested for group A, interest for group B. We're doing a certain workout routine for a month, and then let's say how much muscle gain happened initially versus final, those kind of thing. It is quite common type, ladies and gentlemen. Some of those that doesn't use self-selected sampling is obviously the one that involve animals, because animals cannot participate. So some of those that use white rats for immunization testing, ethical question, I know, but those are not self-selected. Those are more simple random selected. The next example is a Convenience sampling. You probably have this experience, or you may not, because time to time Edmonton big mall like West Edmonton Mall or big grocery stores and superstore, they generally have this kind of survey that is asked for the customer specifically. So what is convenience sampling means? Convenience sampling applies to only members of the population who are convenient to include are selected. So what I mean by that is not everybody is selected. People who are, how can I say, the targeted population and on small portions of that targeted population is included. So like the example that I put in here, grocery survey. If you do a survey about grocery, probably it's a good idea that you will ask in a grocery to do some kind of survey. Now, it will be something related to grocery, isn't it? So it doesn't make sense for me to have that grocery survey in a somewhere else than grocery survey because there's no point. If you're the one who work in a certain grocery store, like IGA in Devon, for example, then if you are interested in doing survey that will benefit or help modifying the system of IGA, you will conduct the survey to the IGA. Sorry. If you think about some kind of randomized any mall specific related, they can do a big shop like in web, something like that. So convenience sampling situation is quite tough to do in this specific, how can I say, project, because we need to go some places, but it is tough to do sometimes because we don't, it is, how can I say, COVID time, first of all. So let's go to another type. This is known as stratified random sampling. I want you to look at the method. It is not cluster situation. It does have its own grouping, and from that we have a random person that is picked each of the row. So that should give you a little bit pictorial idea. Stratified random sampling basically show some members from each group of the population are randomly selected. So for instance, if we use a situation, let's say the first row is Mr. Kim's personal friends list, Mr. McGuire's personal friends list. Let's say he has a lot of friends, and Miss Boynton's personal friend list, which represent green. So my friends, McGuire's friend, Boynton's friends, we are randomly picking list from those. You can think it in that way too. If I being more professional, think about this way. Think about, actually friends is kind of vague. Let's say this is staff member from Holy Spirit Catholic School. This is staff from SPA, so St. Peter Apostle. This is from St. Mary's School in Westlaw, which is a school that I'm from before Holy Spirit. So imagine we have those three schools and then they randomly pick example represent. I think that's a little better example, sorry. Maybe it's a good idea to scratch that friend situation because there's something that is related to that happen in the other ones. And it's more personalized. Let's put more professional situation. So in this example, let's say Mr. Brown chose 5 random students from each grade of Holy Spirit Catholic School to answer some teaching staff survey questions, something like that. All right, let's do classic example number 1. What you need to do is basically identify the sampling type and explain if the sampling method is appropriately done. So I want you to pause this video, copy the question, respond to each of the question, then replay. I'm gonna go over. I believe at this point I will assume that you did. after pausing. So let's go through that. First thing first, we have student leadership team, like in grade 9, which is quite specific to your example. Who wants to find out if students would like the cafeteria to have longer hours? So there was a sampling situation happen. Every student's name is put in the box and 100 names are selected randomly. So this is a classic example of random name out of the hat. So that means I want you to put that this specific example is technically involved for your, how can I say, simple random sampling. That is identified type because everybody have a same chance of getting picked. Is this an appropriate method? I like to say yes, relatively compared to the other type, because you are picking from grade, let's say if it's our school, K to 9, all of the population, we are picking random sample. The only problem that you can think of is as long as you avoid some bias number. Like it's really impossible, but let's say you are picking 50 people and let's say turn out to be entire one of the grade and others, then it's not random, isn't it? So as long as you can put that into consideration, then you're good. Now let's do this situation, second situation. I want you to pause this video, copy, respond first, and then we're gonna go through. At this point, I will assume that you wrote and put some example of your answer. So let's go through that. Each person on the leadership team asked her or his friend. Technically, I can think of few, but one best example that I can think of is, oops, here we go. Convenience sampling. Some people may say stratified sampling, but in this case, and I know I use my quick example of stratified, but I change it because of one thing. Because of this. If you ask your friend and then if the other friend say yes, then it becomes volunteer, isn't it? Because of that possibility, I scratched that idea. Convenience sampling is the one that I can use. Same deal. I want you to copy the question C, answer in your own way, and then go through whether it's appropriate or not. Right, let's go with that example. Before I go through, come to think of it, I didn't go through whether the choice B was an appropriate one or not. The asking students friend. So I like to say when it comes to B method, it may not be appropriate to represent objective data. The reason being is if you ask your friends, then sometimes you, unless you really be careful of using the language, they because it's your friends who's participating, you may notice that they may give you some kind of bias answer too. So you gotta be careful. In any case, so I'd rather choose a simple random situation. Now, next part, every 5th person entering the school is selected. So we first of all know the pattern. Oh my days. Every 5th person. We know that as soon as that happened, okay, we have a pattern going on. So I would like to say that this is interval or systematic sampling. I like to say this method is rather appropriate because if you think about And I know this can be argued, but if you think about students who enter the school randomly, well, that's a fancy way of saying you are doing some kind of survey and you're not controlling who's coming first to the school or who's exiting the school. So the thing is, you are actually being little, how can I say? You are doing things randomly in addition to systematic. So I like to say combination of those two give you a good possible result that may avoid misrepresentation of the data. Same deal, I want you to do it. I assume that you finished D now, so I'm going to go through. An announcement is made asking anyone who wishes to participate to fill in a ballot. So definitely, as soon as you think about, oh, who like to volunteer and so on, this is the one where self-selected method, if you will. Is this a good representation of if you like to go have a cafeteria to have a longer hours? It's quite debatable, isn't it? I like to say try and go to X. The reason being is if let's say a lot of your friends are the one who volunteered to do the ballot, then there is a possibility that bias pattern can happen, or it may be not random. On the other hand, if you actually achieve a random sampling situation by undergoing this, then you know what? You're on the right track. So have that in your mind. Right, I believe at this point you're finished, so let's go through. First thing first, oops, darn it. First 5 boxes each morning. Now, is this a good way? I doubt it's a good way. Because first of all, there's a better way of doing it. First 5 boxes, well, what about random 5 boxes or every 5th boxes throughout the day? Then it's better, isn't it? The reason being is, what if, and this is actual situation that industrial revolution and so on, they did some survey too, and this is true too. Quite a lot of workers are more, how can I say, more efficient during the morning AM working time than PM working time. I'm not trying to say they're a slacker, but I'm just saying. And nowadays, yes, we do have a machine and so on, but still, if you like to go through the quality insurance situation, well, randomize a little bit. Instead of first 5 boxes every morning, why don't you go random 5th boxes throughout the day, or every 5th box, and then you collect 5 boxes, something like that. That would be the better situation. I want you to copy B, or you can directly answer B, which is suggesting 2 other methods. I believe at this point, I will assume that you're done. It kind of overlaps with the example that I put. First thing first, I will suggest systematic or interval and little time condition at random time. That can be one. Or if you think about second situation, why don't we do an actual simple random situation? put a number on each box, and then you're taking out of the hat, something like that. That's rather better objective situation that you can do. That is today's lesson. You have a homework to do, and I want you to go to the Math Makes Sense 9. I believe this is chapter 9, textbook page 448, 449, 4, 5, 6, 7, 9, 10. So 6 questions. I want you to give it a shot.